Recording. The breakdown of questions on the exam is as follows. This is a single file reading question. This 10 points for a single file reading question. 20 points over here for another file reading question. That one I break up into multiple parts. Basically saying, hey, it's 10 points to do this, 5 points to do this, and 5 points to do this, right? Where I break it up into contiguous parts. So. And that'll make sense when you see it, but it's also an easy way to get partial credit on stuff and easy for me to just have a rubric on it. I can't remember. I think this one is, this one's a small method, a very, very short method for 5 points. Very, very small function for 5 points, and a very long, and a regular question for 10 points. Another question for 10 points. 2 questions for 10 points. Another question for 10 points, and then the other 20-point problem, which is a Monte Carlo problem. So file readings, methods, and then Monte Carlo. So with regards to the actual practice exam, this first page that we're about to go, which I'll go over right now, these are really just kind of hints as to what you should really know off the top of your head on how to do. Well, except for number 2, but that's okay. So the string Hal's moving castle is a valid string. Why isn't it a problem that the single quote character from the word Hal's isn't escape? So in other words, in Python, what we're saying is that Hal's moving castle, that's valid as a string. And it's valid because even though a quotation mark also starts and ends a string, if we start a quotation mark, if we start a string using double quotes, then it ends using double quotes. If it starts using single quotes, we end it using single quotes. So if you want, so here, if we did have single quotes like this, that would give me an error unless I escaped it. So just know that there's that basically, yes, just because you can use single quotes and double quotes, that does kind of impact how you can use strings. The second question is, what is the difference between a dictionary and a list? And the answer is that a dictionary uses essentially the smallest answer I can give to that is that a list relies off of indices, right? L dot, and you can append stuff to it without having to specify the index, and it'll just slap it onto the end. But basically lists have indices, right? And they're ordered. Whereas dictionaries have keys, and you have to define what keys you want in a dictionary. The advantage, of course, is that the keys can be anything you want, not just numbers. That's the main difference. All right, this one. If L is a list, what does this expression do? Anyone? Yes? Yep, this creates a copy of the list in reverse. By the way, it's not important to know that, it's kind of important to know that it creates a copy, but more importantly, it reverses it, right? This will give you the reversed list. All right, this one. How can I use slice notation to get the last 3 characters of a string? Let's see. Let's go back to our Python thing, right? What if I want to get TLE out of Howl's moving castle? Anyone? Yes? Yeah, you can go again.
Take a slice of third to last to the end.
Yep, third to last to the end. -3 to the end, right? -1, -2, -3. That'll get you the last. So that's how you can. So remember, that's how that notation works, and it's just short for len of s -3 over there. Third to last index, all the way up to the end. All right, how can you simulate a coin flip in Python? kind of like a bunch of different ways actually, but you have to use random. So there's a bunch of different ways. So long as you've got two outcomes, if you're using random and you've got two outcomes, then congratulations, your answer's right. So import random, right? So if you used random.randint 0 to 1, which gives me a 0 or a 1, congratulations, you're right. If you used 1 and 2, congratulations, you're also right, right? Because there's two possibilities there. If, on the other hand, you use 1 and 3, you're probably wrong because there's now 3 possibilities. Okay? A coin flip, by the way, remember, is 50-50 shot. Okay? I have a coin and it's slightly weighted in favor of heads. It lands on heads 55% of the time. How would you simulate this using the random module? There's a bunch of different ways. There's some like kind of weighting you can do internally with the module, I think, but there's a couple different ways to do this. So let me just tell you that yes, did you want to? Yeah, go ahead.
I did random.choices, then you can apply like weights to each of the choices in the list.
Right. So how did you apply your weights to your choices?
First I made a list, and then I did,
With just 1 and 2 in it, or?
that's fine, I did heads and tails, but
Yeah.
yeah.
Okay.
Then I did random.choices, the list, comma, a new bracket, and then the weight for each one, so I did 0.55 and 0.45.
Right. And that's something we didn't, and using choices like that was not something we went over in class, and that's perfectly fine. But remember, random.choice, was there choices? Yeah, random choices, and then you can say, hey, I want 55 for the first one and a 45% chance for the second one. And so you can give that, and now it will react accordingly. And if we run this enough times, we'll see a divergence. Okay. Another way to do this is, and this is going to seem really stupid and really silly, but is to also use random.choices, but we're going to do it with one list, and we're not going to put any weights. Namely, what we're going to do is we're going to have outcomes equals the list heads times 55 plus the outcome tails times 45. And guess what that does? That gives us a list with 55 heads and 45 tails. And then random.choices, let's see, on outcomes, that'll be, or rather, let's see, I think random.choice, yeah, random.choice on that outcome basically will pick one at randomly from that entire big list. And because there's 5 more heads, sorry, there's 10, because it's weighted 55 heads and 45 tails in the list, it will come out to that outcome. And one other thing you can do is, like, you can generate one other thing I'll just describe here. Another simple thing is just random.randint 1 to 100, so 100 different numbers because it's inclusive, and just simply say, hey, if it's less than 55, it's a heads. Otherwise, it's a tails. Or if it's 45 or less, it's a heads. Sorry, 45 or less, it's a tails. And so you can create an if statement around that. So that there's a bunch of other ways to do that. That one is less important, but it's more just basically think about how you can use the module, the random module. All right. Write a method called hasWildcat. This is one of my favorite ones to do. Given a input string word, return true if the string contains cat in it, but the middle A can be any character. So, because this is one I give in both classes where I teach regular expressions and where I don't teach regular expressions, because it's great for both of them. So, all right. Now, Kitty becomes false because it doesn't have a C anything T combination. Yes?
I don't think we have that
What's wrong with it?
Never mind. I found it. We just had it in a different location. My bad.
I have no idea why it's in a different location.
Number 17.
Did I mess it up? Did you have the Monte Carlo one? When in the world did I post? Yeah, I posted one in the announcements for this exam, I believe. Yeah, there was one from... Yeah, I made an announcement. I posted it when I was done. Practice exam. Yeah, so I mentioned that basically I had a bunch of old practice exams from last semesters that had regular expressions on them. So this is the one I'm going off of. And I do believe, yes, they are in different order, which is interesting. Okay. No idea why that is. No idea why that is. Yeah. Okay, so I'll download this and go over this order. But yeah, we do have the Monte Carlo method. Great. No idea why that is. Okay. Because I put a lot of effort into that Monte Carlo one. Okay. So suppose we have a file that contains the contents of every information every student at Temple University called students.csv. Contains the various information on each student, each with a student having a single line for their data. Each line has the following fields: ID, first name, last name, age, major, credit, right? So this is what an example file might look like. Okay. Write a program that reads and finds the average GPA for all students above the age of 40. Okay. So what I'm going to do is just copy this so it's going to be here to look at, and pass on this so that it's not going to crash my compilation or anything like that. Move this over here. Boom, boom, boom. Boom, boom, boom. And now just slap this in here. Okay. And then view. I was going to do word wrap on, but what? Document. Line wrapping. There we go. Okay. Write a program that reads the file and finds the answer. So def read def GPA problem. Okay. So now we've got a file called students.csv. So the answer for this one is pretty straightforward. We read the file. Data is equal to open students.csv. Open it and read. Doesn't matter whether you use single or double quotation marks there. And then to iterate, then what we're going to do is we have to do the average. There's essentially two ways to do it. First is you can store all the GPAs in a list and then sum the list and divide by the number of things in the list. Or you can just do a running total, which is what I'm going to do. Total is equal to 0. So we're going to add up all the GPAs, and then we're going to divide them by the number of GPAs we added up. This will make sense. For line in data, okay, line is equal, so this will read one line at a time. Line is equal to line dot split. This will turn the list into this will turn the string into a list. And it will split it up via the comma. Okay, and now because it's a list, let's go ahead and see. What we care about is the age and the GPA. Age is index 0, 1, 2, 0, 1, 2, index 3. So age is line index 3, but age, since we're going to be comparing the number and it's an integer, let's convert it into an int. And then we care about the GPA, which is the last field in it. So So this is one student at a time. The GPA is float line -1. Okay. Yes.
Won't the first line have the student ID and all those stuff?
No, not for this one. Each line has the following fields, so a file might look like this. If we did, we could just simply skip the first line if we needed it to for that. So we've got our GPA, we've got our age. If age greater than 40, total plus equals GPA, so add the total by that much. Count plus equals 1. And then all I have to do is, then that goes up through, and that's literally it. That will go through everything and add up all the GPA and the number of number of students who are above the age of 40. And now to get their average, I would just print total divided by count, right? Add up to compute an average. Remember, you add up all the things and divide by the number of things you added. So here I added up all the GPAs and divide by the number of GPAs. But we only added them if the person with that GPA had above 40 in age. It's a fairly short program to do. Okay. I think there was extra practice on that one, which simply said finds the student, write a program that finds the student with the lowest GPA. So if we want to find the student who had the lowest GPA, that's fairly straightforward. Again, we just care about the age and GPA. Worst student is equal to blank. Worst GPA is equal to a 5.0, right? So anybody who's got lower than the current worst GPA now has the worst GPA. So we just simply say, hey, if GPA less than worst GPA, congratulations, that GPA is now the worst GPA. And then the worst student is equal to line. Line 0. And then plus, and that's a string. Plus line 1, I guess. That'll get their first name, last name. Yeah, that should do that just fine. Maybe a space in between them, but that's fairly straightforward, right? To find the lowest thing, you basically say, hey, this is the lowest thing I have so far. If the thing I'm looking at is lower than the lowest thing I have so far, that is the new worst thing, or lowest thing, or smallest thing, depending on how that works. Okay. Why is this that one? Yeah. Close without saving. All right. Finds the oldest student, and then finds the median GPA. So I'll go through the oldest and then the median very quickly. So, same for this one. Oldest student is equal to blah, and oldest age is equal to, or rather let's call it max age, is equal to, I think, let's go with 2. Okay. If age is greater than if age is greater than max age, then congratulations, you're the new oldest student. So we just simply say max age now has age stored in it, and oldest student is now that. Right, and I'm just doing it in the same program rather than rewriting it a bunch of times. All right, the last one is tricky and probably not anything you're going to have similar on your exam, but find the median GPA of all students. And the way we're going to do that is that I'm going to create a list called GPAs. and that's going to be equal to an empty list. Simply, as soon as we grab a GPA, we are going to say GPAs dot append GPA. Okay. And now to get the median, that's the middle item, right? So let's think about this for a second. Let's draw it. Right, if I have 5 items in order, 1, 2, 3, 4, 5. The length of this is 5. 5 divided by 2 gives me 2.5, which really doesn't help. So I want to get, what index is the middle thing at? It's at index 2. So we did 5 divided by 2, give me 2. If I had 10 items, 6, 7, 8, 9, 10. If I had 10 items, it's even, so there is no real middle. But I'm okay with just simply just grabbing the left item and calling that the median. So to get the median, we'll just simply grab the thing in the middle index, which means just divide by 2. I think technically you're supposed to like divide by, no, divide by 2. Yeah. I've got 15 items, then I'd like the index at, the middle index will be, well, I've had 15 items, so I'll have 7 to the left, 7 to the right. And so I'll be at index 7. Yep, so divide by 2. So GPAs, append to the GPA. And then if we want to print out what the middle item is, we just simply print it, or the median GPA. We first do sorted GPAs to sort it, right? Because the GPAs won't be in order, but as soon as we sort it, it is. And now print GPAs divided by 2, or rather, not GPAs, sorry, length of GPAs divide by 2. That gets you the middle index. And we want the middle index of GPAs. Looks weird. Basically, we're saying, this is the middle index over here. Give it to me, please. Again, you're not going to need to know the middle for the exam. It was just a useful thing that hopefully you could have fun trying to figure that one out. Again, I want to go through a lot of these, so I'm going to keep moving on, and it will be in a recording. All right, suppose you have a file named numbers.csv, which contains a bunch of integers, 5 per line of text, separated by comma. Write code below that'll open the file, read the numbers from it, and print out the sum of all the even numbers. For example, this is what the file might look like. You're going to have a really bad time, by the way, if you think my examples are the actual problem. Like, if you try to solve the actual problem by basically saying, hey, add this index, or something like that, and you're just doing it off the literal example, not going to be good. Def, even, file, sum. All right, so called numbers.csv. So data is equal to open numbers.csv R. Open it in read-only mode. For line in data. Line is equal to line.split. You don't have to split everything, but when there's multiple things in when you have multiple things in a line, you do need a split. Like when you have multiple fields in a line, you'd want to split. If you're just going through something like a list of words with 1 word per line, or usernames where 1 username per line, you don't really need to split. So for line in data, line.split, we'll split it up via commas. For item in line, so for every item in line, because here we're not going after a specific one, we're going after all of them. Okay. And also I didn't specify how many would be per line, so we have to iterate through all the items. So for item in line, num is equal to int item. Got to turn it into an integer, or we can just actually make sure. Item is equal to int item, so we turn it into an integer because they're numbers. We need to do a running sum, so sum is equal to 0. And then if item mod 2 equals 0, so if the item is divisible by 2, sum plus equals the item. And that's it. That's all you have to do to calculate the sum. Print sum. Right, go through, right, take every line, split up the line by commas. For every item, I'll give you a list. For every item in the list, turn it into an integer. If the integer is divisible by 2, add it to the total. Okay. So, methods, into the methods now. All right. A lot of these, some of these, the answers to some of these on the exam will be short, especially if you are able to do your slicing. On the and I mean that for the actual exam. On the practice exam, we've got a number of them. So on or on, one of my favorite practice ones. If it's got on at the beginning, then remove the un. If it doesn't have on the beginning, add an un to it. I feel like it's a fairly self-explanatory one, and it's fairly good. So, un or un. All right, so first thing we have to do is just check. Does the word start with un? That's really it. So, how do we tell if the word starts with un? Well, un is 2 letters, so just let's check the first 2 letters of the word. So, if the first 2 letters of the word, right, get the slice at the first 2 letters of the word. Got to really know your slices for this exam. If word mod 2, if these are the first 2 letters of, and remember this goes up to but doesn't include index 2. If that's equal to un, then we want to remove the un. And I'll remove that comment in a second. Otherwise, add un. That's it. If this is true, then there's an un there to be removed. So how do we remove it? Very simple. Just return word starting from index 2 and going to the end. Right? If it starts with un, return word start at index 2, go to the end. Kind of nice and symmetrical like that. Otherwise, we need to just return the word with the number un, with un added to it, in which case that's simple enough. Un word. That's all. Guarantee you there's a question basically as simple as that can be very close to as simple as this if you know your slices. This one's also not that bad. Min-max different. And I keep this in here specifically because it's one of the complaints I get from from our 1068 instructor. He says, make sure these students know how to find the biggest thing and the smallest thing in a list. So, here we're going to find the biggest thing and the smallest thing in a list, and we're going to subtract them. Okay, or not. Copy. Paste. All right, so here we want to find the difference between the minimum and maximum. Here it's 4 because 5 minus 1 is 4. 16 is because the biggest thing is 31. The smallest thing is 15. 31 minus 15 is 16. And then 200 minus negative 100. 100 minus negative 100 is 200. That's why we get 200. Min-max difference. Okay, now, yes, there is a one-line solution to this for those of you who have figured it out. So pat yourself on the back if you just simply did return max numbers minus min numbers. Congratulations, one-line solution in Python because that's all it takes to find the minimum and maximum in Python. However, let's assume you don't know about min and max, and we actually need to do it. Let's go ahead and say I'm going to go ahead and say biggest is equal to. What I'm going to do is say the biggest number in the list is equal to the first number. I'm going to choose that one by default. Could be the last one, but whatever. And then I'll say the smallest number is equal to. I just have to give it an initial value. So choosing something out of the list is a good initial value. Small list. For n in numbers. So for every number in the numbers, if n is bigger than the biggest number, then guess what? That biggest number is now n. If n is smallest is smaller than the smallest number, congratulations. Smallest is now equal to n. That's all you have to do to find the minimum and all you have to do to find the maximum. Just simply go through and just keep track. Yes?
What if we sorted the list that was subtracted from the last and did that with the initial index?
If it works, it works. That does work. You can sort the. So what he asks is, what if I sort the list and take the last item and subtract it from the first item? Or sorry, other way. You take the first item and subtract it from the last item. Yeah, it's perfectly fine if you do this. And then return biggest minus smallest. Okay. Swap ends. Given a list, modify the list such that the first elements and last ends are swapped. It had slashes on there because it came from my Java practice exam, and I forgot to update the comments to be proper Python comments. So let me fix that over here. So here we're swapping the ends. We've got the same examples as last time, but here what we're saying is 1 and 5 get switched, the 15 and the 28 get switched, and the -1 and the 100 get switched. Now to do a swap like this, what we need is a temporary variable to hold them. Temp is equal to let's say the last item in the. So essentially, actually, we can just simply store them both and make it easier to see rather than trying to juggle them around and making it hard to look at. So to do this, we need to swap the first item and the last item in the list. Okay, numbers. The first item in the list is this guy, index 0. What's the last item in the list? Numbers, -1, right? Then all we need to do is say, hey, numbers 0 is equal to first, not numbers -1, because that can get tricky. And and then numbers. So we want to move the last number into the first location. And then we want to take the first number and move it into the last location. And that's it. The other way to do this is to use a temporary variable, which is to do it like this. Temp is equal to numbers 0. Take numbers -1. Take the last item, take the first item. Store the item from last place in there. And then take the temporary stored item. and you can't say number 0 here, right? You might think, hey, just do this, just these 2 lines will do it. But here you'd be saying, take the last item, put it into the first item, and take the first item, which is now the last item, put it into last item. So you'd just be overwriting. So instead what we have to do is we have to create the temporary variable to save the item that we had and put it in there. So this way works, this way works. Okay, making good pace so far. All right, so these problems are from Coding Bat. So you can check your answer from there. So we'll say a value is everywhere if for every pair of adjacent items in the array list, one pair is that value. Return true if the given value is everywhere. So for instance, we're checking if 1 is everywhere. 1 is part of 1, 2, 1 is part of 2, 1, and 1 is part of 1, 3, so pairs. 2 is part of 1, 2, it's part of 2, 1, but it's not part of 1, 3, so it's not everywhere. 1 is part of 1, 2, 2, 1, 1, 3, but not 3, 4, so it's not everywhere. So that's what we have to check. Basically, for every pair of adjacent pair, does that item appear? It's really not too bad. Okay, so I'm going to do this with a minor mistake first and then go back and fix that mistake. Okay. Is everywhere. Source. Okay. So here we can't just go through one number at a time. We actually have to use the indices. So for I in range length nums, and we have to use the indices because we're going to be going over 200 numbers at once. I'll say for every pair of items, you have a left pair and a right pair, okay, or a left side and a right side. The left side is the item at I. And the right one is the guy who's to the right of the left guy, which means he's 1 over, which means he's at nums index plus 1, so I plus 1. And this is where basically our mistake comes in. Because we've added a plus 1 here, once we get to the last index over here, and we try to add plus 1, we'll go out of bounds. So what we need to do is prevent that since we're going to be looking 1 over to the right, we'll stop before we get right to the end. And instead, we'll just look 1 to the right over here, and then we'll stop. There's no need to check 3 and his next partner, because there's nothing to do there. Another way to stop that is once you detect that you're at the last index, you can just simply say continue or break. But I like this way better. Anyway, now all we have to say is, hey, if left is not equal to the value and right not equal to the value that we're searching for. So if we're looking for it in this pair, and if it's neither left or right, if it's neither of those pair, then it's wrong, so return false. It's not everywhere. False. And otherwise, if we get through everything, return true. Wish I knew why I was so tired going through this. Probably need some water. All right. So, this one. All right, so I'll go through 14, 15. Yeah, I should have plenty of time. All right, so given a string, return the sums of the digits from 0 to 9 as they appear in the string, ignoring all other characters. Return 0 if there's no digits in the string. So we're just simply adding up all the digits that occur in a string. So here, right, 1 plus 2 plus 3 is 6. 1 plus 1 plus 3 plus 3 is 8. And then there's nothing to add over here, so we return 0. So this one's actually fairly straightforward, which is total is equal to 0, return total, and we'll just simply go through and increment total. For letter in word, or another thing we can do is for character in the word. So just simply go through every character and ask, hey, is this a digit? A couple ways to do that, right? We saw that there was a car. So first off, if car dot is digit, we'll return whether or not that is a digit. Then it's pretty straightforward. Total plus equals int, because we've got to turn it into an int, car. Turn that letter into an integer, add it to the total. Yes?
Doesn't that return true or false?
What?
Char that is digit, it returns either true or false. It shouldn't, like, if it's true, then
There's no need for, so there's no need to do an if equal true over here. If you do it, it won't hurt, but there's no need because basically it condenses down to if true, right? Because remember, what this will condense down to, this expression condenses down to either true or false. So I'm just skipping the middleman and saying, hey, if it's true, run this. If it's false, don't run it. So if character is digit, add the value to that character to the total. Another thing we can do is say, if we didn't have the is digit or didn't know it existed, you could say if character, well, the tedious way would be if character is equals 0 or car equals 1, but that's super tedious. The less tedious way is if car in 0 through 9. And that also will work just as fine. All right. Let's go ahead and take a look at another one. Given an integer, return the sum of the digits from 0 to 9 of that integer. This looks very similar to the problem on the actual exam, where basically you were asked to multiply, give the the product of all the digits in the number. So again, total is equal to 0. Return total while oh, sorry. Okay. So while the way we solve this again is while number is greater than 0, last digit is equal to num mod 10 to get the last digit, and then add total plus equals last digit. I mean, we can also just skip this step and just simply say, hey, increment it by this instead. But I figured it'd be more explicit. And then we remove, so we've added the last digit in, and now we can remove the last digit. Which is num divided by 10. That's it. That's all you need to do. All right. I'm going to skip the copy evens for right now, and I'll come back to the wildcat. And to the, I'm going to skip these problems because they're less relevant to the exam. And I want to make sure I give this one the appropriate gravitas it deserves, I guess. All right, because I was very proud of this. Okay, so because part of statistics is basically figuring out whether or not you're being scammed, right? So the idea here is that we've got a fair coin toss. You flip a coin, it's going to land heads or tails, 50-50 shot, right? If it's a fair coin toss. And if you toss 3 coins in a row, you've got these 8 possible combinations. They can go all heads. The last one can be the tails. The middle one can be the tails. Just the first one can be heads. Only the first one can be heads, first and last. Tail, tail, heads, and then all tails, right? Those are the 8 possible combinations. There's not an imaginary 9th combination. All right? So in this sequence, head, heads, tail, HHT means heads, heads, tails. I threw a heads, then a heads, then a tails. So suppose I decide to challenge you to do a game for $100, which is highly unethical for a professor, but hey, this is an exam, and I'm able to do what I want in exams. So I'm challenging you to a game for $100. And what you're going to do is that you are going to choose a sequence, such as heads, heads, tails. And then I'm going to choose one called, such as tails, heads, heads. And then we decide one of us, it could be me or you, and I'll keep flipping a coin until one of our 3 flip sequences occurs. And whoever basically shows it, basically we'll keep flipping a coin until we get the pattern heads, heads, tails, or tails, tails, or tails, heads, heads. And whichever one comes up first is the winner. And that seems fairly fair, right, at the first glance, right? All three sequences are equally even. They have an equal chance of happening. So like here I flip heads, tails, heads, tails, heads, tails, heads, heads. That's a win for me, right? Because we didn't have any of the patterns until we finally got to tails, heads, heads. And now my pattern came up, right? Your pattern hasn't come up yet. My pattern hasn't come up yet. Oh, there's a tails, so it might be the start of my pattern. A heads, if I get one more heads, I win. Woohoo! Whereas over here, heads is the start of your pattern. Oh, it's tails. Heads is the start of your pattern. Doesn't matter. Here, you do heads, then another heads, and a tail, so you win. Okay? Here, we do tails, tails, heads, tails, heads, heads, right? I threw a tail, then another tail, then a heads, tail, but I get heads, tail, tail. But I get tails, heads, heads before you get heads, heads, tails. So I win. And here you throw a heads, and another heads, and at this point the game is determined, right? As soon as another heads comes up, you win it by default because that'll be heads, heads, heads. So it seems like a fair bet. But you remember I joked that I'm a trickster and I'm a jerk. So when it comes to some things, sort of into Slytherin, in fact. I wouldn't actually play this game unless I was sure that I was at a very good chance of winning a lot of money. So the idea here is write a Monte Carlo method to scamming. And you'll notice actually with this is that actually tails, heads, heads beats tails. Heads, tails, tails a lot of the time, right? We can start a sequence, right? The only way you really win is that if you get 2 heads in a row. If you get 2 heads in a row, you're short of victory there. But, and then because as soon as you throw a tail, you win. But you have to start out by throwing 2 heads in a row. If you don't start out by throwing 2 heads in a row, essentially it's my win. Heads, tails, heads. And then, let's see, if I were to get another heads, I'd win, right? If you were to get a tails over here, then that's then I haven't won yet, but you need heads, heads, tails. But at this point, it's not going to happen because for you to get 2 H's, it has to come after a tails. So this is actually called Penny's game. And it's all basically off the fact that basically you can pick a pattern that has a part of the other person's pattern that will slaughter their pattern. And there's a nice link down here you can click. You can watch it on basically it. The statistics are awful, but that's why we do Monte Carlo methods, okay? And what we have to do is that we have to basically throw 3 flips. So how do we do this? So let's go ahead and write a program on the next page. Write a program that simulates the game on the previous page where one player is trying to get heads, heads, tails, and the other is trying to get tails, tails, heads. You can also simulate other ones to see how they compare. Have your program simulate 100,000 times and print out the percentage of times the 2 players win. Okay? So let's go ahead and copy this into our thing over here. So we have basically our first choice over here is whether we're going to be dealing with heads or tails or 1s and 2s. And I think I'm just going to go with the additional overhead of just doing heads and tails. Okay, def head tails. I'll just call it head tails. Okay, so our winning sequences are, let's see, Rosen is equal to tails, heads, heads. Student is equal to head, head, tails. Okay. Now, one way we can do this is that you can simulate. There's 2 ways to essentially simulate the coin flip with heads and tails. The first is to basically do a random integer between 0 and 1 or 1 and 2, and basically say if I get a 1, it's a heads, and a 2, it's a tails, or if I get a 0, it's a heads, and a 1 is a tails. Doesn't really matter. The other way to do it is do this. Outcomes is equal to heads, tails. Now this is useful if you're doing with coins. And then basically just flip a coin that way. Just do random.choice, which selects 1 from there. On the actual exam, I'll give you a little heads up. You're going to be dealing with dice just like you do in your homework program. So you don't need random.choice. You just need random.randint, right? So you don't need to do random.choice. It's an easier version, right? Will be another game too. Game that, if you're American, you've probably been tortured before with, and I don't know about other countries. I'd like to think that we've exported basically a lot of our stuff, but I don't know. All right, heads or tails. Okay, so we need at least 3 rolls first, right? So basically this is fairly straightforward. We're going to need at least 3 coin flips, right? So flips is equal to an empty string. We need at least 3 flips. So let's give it our first 3 flips. Actually, and we need 100,000 of these. So for I in range, 100,000 of these suckers, right? We need at least 3 of these flips, so let's go ahead and do them. For blank in range 3, let's do our first 3 flips because that's the minimum we need. Okay. And then, right. So outcomes plus equals. So here we're going to, or not outcomes, but flips, which is our accumulator, is equal to flips plus random dot choice outcomes. Okay? Basically what we're saying is choose heads or tail randomly, the string heads or tails randomly, and add it to the string flips. If we were using randint, this would just simply have a couple of if-else statements in there. It would have a single if-else statement in there. If it was a 1, add an H. If it was a tails, does so, but I prefer this because it's a shorter statement. Okay, and now what we have to do is that we need an indeterminate loop because we don't know when this is going to end. We know it's going to end though when the last three characters of flips is equal to Rosen or student. So fortunately on the exam I did ask you how'd you get the last three characters of something. There's a method to his madness. Okay, so while the last three characters, while flips the last three characters of it, so that would be last three characters to the end is not equal to Rosen and flips the last three characters are not equal to student. Okay, so while we're still waiting for somebody to win, flip the coin again, right? While the last three characters, and the reason I had to split this up, by the way, is because we needed to, we couldn't really do this. No, actually, hold on a second. Python's weird like that with slices. Flips is equal to, let's just do heads. Okay, great. So we actually didn't need this. We could just simply said, hey, while the last three characters of this are not this, then just simply flip the coin. And once the last three characters match Rosen or it matches student, then excellent. There's nothing wrong with the way I did it before. All right. So we've got that. Now we need to now we just need to tally up who wins. Results is equal to a dictionary, right? Winner is equal to flips. Negative. We don't really need to check if Rosen won or student won. We can just simply grab the last three flips, right? We just can simply grab the last three. Right? Somebody won. It's either Rosen or student. So just grab the last three. We'll know who that is. And just simply say, hey, if winner not in results, well, then that's the first time we've seen him won. So results for the winner, one win. Else, well, we've seen him win before, so grab all his previous wins. It's almost like I've deliberately chosen my assignments to build up to, or chosen this question to build off the assignments we've been doing. Winner is equal to results winner plus 1. By the way, if I were to tell you to review any specific assignments, it would be the Pig Latin assignment and the Pig assignment. The most recent assignment, the Pig one, specifically like the first three exercises of it, not the entire game. Those would be good ones to review, because that's slicing and Monte Carlo methods. Okay, so that's not to say don't look at the other ones, but those are ones I specifically target because I know I specifically put questions about slicing, which is what Pig Latin did, and then questions about Monte Carlo. Anyway, that's it, actually, for this one, except for the fact that we need to print our results. And let's actually see how this works out, because aren't we interested to see how often I'm winning that cool $100. Yeah, so gonna get fired if I actually did that. All right, where did I forget? Line 65. If, okay, weird. Item mod 2 == 0. Sorry. Okay, we're 156. Okay. Wouldn't be a program written by me unless I forgot a colon. Random is not defined. So on the exam, by the way, you can always assume that everything you need, every library you need, is imported. Okay, so you don't need to import random. So if we look at this, tails, tails, heads wins 75,000 times versus heads, heads, tails 25,000 times. Okay, it's actually fairly straightforward to choose something that will clobber it. So, like for instance, somebody give me a three sequence, heads, tails, heads, or something like that. You know, 3 coin flip sequence. Yes.
Tails, heads, tails.
Tails, heads, tails. So to beat heads, heads, tails, I want tails, tails, heads. The secret and the way to win is what I do is I take your middle coin, flip it. That's my first coin, and then my second and third flip are your first and second flip. That's all I have to do, and that will give me a win, or it will significantly skew everything in my favor. I don't really want to have the time to go into why, but if you want to win like a couple bucks before anybody catches on and the game threads like wildfire, because this is a scam. So don't actually go into it. But if you do it, teach the person the trick afterwards. Tails, heads. So this will win. The YouTube video's on there. But the idea here is that I am choosing the sequence that will occur before your sequence, or at least is part of my, or your sequence is part of my sequence, I believe, is the idea. Some of these are more favorable than others. So, all right. And if you notice, right, the outcomes for this, right, with the, so, and I actually can explain the statistics for this game pretty simply. Tails, heads, heads, tails. The only ways you're going to win with heads, heads, tails is if you throw a bunch of heads before tails comes up, right? As soon as a tails comes up, I've got to win, because that means that, if it's a bunch of tails, if we keep going, if we get tails, 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 heads, tails, tails. As soon as I get a second head, I win. There's no way for you to win anymore. You have to have 2 heads, but those 2 heads will always follow a tail as soon as that first tail comes out. So for you to win, you have to throw 2 heads as your first toss. Now, what's the chances of you throwing 2 heads? 50% chance times a 50% chance gives you a 25% chance, which, there you go. It is a very cruel and unusual game, as all scamming games are. Anything that looks like it's easy money isn't. Yes? Oh, to show the percentage? Yeah, we should totally do that. To do that, you'd want to... Okay, yeah. Did I say to do the percentage? If you want to do the percentages, it's for key in results, print key results, key, and then we did 100,000. Thanks. I'd forgotten about that. There we go. Boom. And there's your percentages. Just instead of taking the print, I did a for loop. So I'd print the key for the dictionary and then this dive it. and then the number of times you won divided by the number of items, so that we'd get a percentage.
When we remove it from dictionary, it automatically targets the keys.
Yeah, when you iterate over a dictionary, you automatically get the keys. Always goes over the keys. If you want to be explicit, you can go .keys. If you want the values, you can do .values, and if you want to get both the keys and the values, you can go .item. But just for key and results, that's how it works. All right, let me go over that last one because it has less to do with slicing. Let me go over that one that I was starting at the beginning that has wildcat. That I don't know why my exam does not match that. But anyway, so given an input string, return word true if it contains cat in it, but the middle A can be any character. So Tomcat was great, Catnip is great, but Kitty is not great because these has CAT, this is C4T, the middle A can be anything. It doesn't just have to be a T. And this is a lot like the other question we had with the pairs. So, right, so we're going to assume the word doesn't have wild, so we're going to return false by default. We're going to assume it doesn't have wildcat in it until we find the cat pattern in there. Wildcat because the middle character is wild. Okay. So, for index in range len word. Now, so let's go ahead and say C is equal to in word index. Okay. So this will get the character that character at index. And now we'll ask ourselves, if C is a C, that's what we really care about. If it's not a C, just keep going. But if it's a C, well, then the next character can be anything. We don't really need to check if the next character is anything, because if it's the character, then good. What we care about is the character 2 characters after it, which is this. Is the character 2 after the C a T? And word index plus 2 equal to T. Return true. Now, if this question, I don't remember how many points this question was worth, but if it was a 10-point question, this answer would give you 7 points out of the 10. And the answer is because it goes out of bounds. Right? Yep, you have to subtract out 2. And the reason here is basically, let's go ahead and take a look at our, so for Tomcat, this is going to work. Go to TOMC, get to C. Hey, is that character a C? Yes, it is. And is the 1, 2 after it? 1, 2 after it a T? Yes, it is. Awesome, return true. But what about Kitty? Is this a C? No. Is this a C? No. Is this a C? No. What about this one? No. This one? No. That's going to work out. But what about something like has wildcat tarmac? Is this a C? No, 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 no. Then you get to the C. Ooh, this is C. And the word 2 after it's a T. Or, sorry, and the 1, 2 after it's a T. Well, what's 2 after it? 2 after it's an error. Out of bounds. So, what we do is that we stop here. We stop here at the M. Because once we get past the M, there is no letters beyond here. Right? There's nothing beyond here which would give us a correct answer. So to do that, we just simply say -2. in general, whenever you're iterating through through a list or a string or some kind of collection, an index-based collection like this, whenever you add some number to look ahead, subtract that amount from the amount you want to go up to, right, to prevent yourself from going out of bounds. Yes?
If you look ahead at two numbers that say 1 and 2, you subtract the biggest one, right?
Yep. Because to look ahead to, you have to pass the 1, right? It's not a bad question, right? No, so he was saying if you have to look, what if I'm looking for cat, for instance? I'm expanding on his question. Let's say you were looking for cat. And word index plus 1 equals A. Right? So yeah, here I'm looking ahead 1 and I'm looking ahead 2. That doesn't mean you look ahead 3. In order to look ahead 2, you first have to be able to go past 1. So we would still be subtracting 2. See, now that's why I like this one. Yes?
For range, do you do +1 -2?
No, because this goes up to, but because range goes up to but doesn't include. So you're starting off with a base of length of word. So that will go up to n-1, where n is the size of it, and then this is the correct way to do it. All right. So I think there were 2 more practice ones there, and I'll just briefly describe that, how they work here. Okay. So for this one, to get the most common letter in a string, I don't have an equivalent question of this in the practice exam. This is just more dictionary practice. To do this, go with the string, right? I could do this in like 2 minutes. So to get the most, so say you're given a string, you want to get the most common character out of a string. Not too bad. Def, most common car given a string S. Counts is equal to a dictionary. For C in S for each character, or rather for character in the string. If I've seen the character before, or sorry, if I've not seen the character before, if character not in counts, guess what? This is the first time I've seen it, right? You should hopefully know this format by now. Counts, car, 1, else, counts, car, equals counts, car, plus 1. So that counts it up. And now to find the most common one, most common is equal to, don't really know what the most common is. Yep, can be empty for right now. And most count is equal to -1 or 0 or what, something less than 1 is the point. For key in counts. If counts, if the number of times I've seen that key is greater than the most counts. So if the number of times I've seen that key is greater than than what I've seen the most so far, and that key is the most common letter, and the number of times I've seen it, sorry, other way around, counts key. Print most common. Oh, if I want to return the most common character, then I just here return most common. And that's how you get the most common character. All right. Last one, which was this one, given a list of positive integers. Yeah, not really something like this on the exam. It's a good practice question. What you need to do is create a new list to begin with. Look through everything. If it's an even number, append it to the list. And once you have and keep account of how many you've appended to the list, or just simply check the length of the list. Once you hit this number, just simply break out of the loop. And that's it. All right, so your exam will be on Thursday in here. If you cannot make it, yes, you have a question. I will post this video. And I'll post this right now. I'll post what I just coded up right now onto GitHub. CD classroom. Wait. By the way, you get a cheat sheet. So in case that wasn't clear. Give me 1 second. Give me 1 second. I want to make sure I upload the code.
I think one of the code is wrong. The code